Hi, I'm Siddhirajan Naure. In the next 5 minutes, we will understand sets and functions, which is foundation for data science. Why sets and functions matter, their core definitions, a quick sport example, and a graph too, and where these ideas drive today's tech. Let's start. In 1874, George Cantor invented set theory to compare infinities. That same language now powers SQL queries and Google's PageRank. Also, functions map input to output, which is essential in calculus, physics, and AI. First, set is just a named collections of distinct items. You will see the curly braces listing style, the element of symbol for membership and its opposite for non-membership. We also flag the empty set with nothing inside, and the term cardinality, which is simple the head count of items. Finally, there is a rule notation, a concise way to describe all items that satisfies a conditioner rather than listing them. Here we see set operations and fundamental properties, which is union. First, A union B means A or B. A intersection B means in both. Difference, A set difference, B means A but not B. And the complement, not A, means everything outside A in some universe. For understanding these concepts in detail, I already provided the one example of intersection. These obey algebraic laws like commutative and De Morgan's law. Here I'm explaining a simple example using two sets. Set F represents students who like football, which is Lam, Emma, and Noah. Set B represents those who like basketball, which is Emma and Olivia. We are interested in finding out who likes only one sport and who likes both. The union of F and B gives us everyone who likes at least one of two sports, and the intersection gives us students who like both sports, in this case, only Emma. This kind of analysis is helpful in many real world situations like planning, schedules, or understanding shared interests. This slide gives a quick look at what a function is. It's a rule that links each input from a domain to one unique output in a codomain. The actual output used from form the range. You can think of functions like formulas such as f of x equals to x square or as simple rules like assigning names to initials. Functions helps us model relationships, process data, and build logic in systems. In this slide, we are classifying functions based on how they behave when mapping inputs to outputs. First, a function is called injective or one-to-one if every input maps to a unique output, no repeats. Next, a function is surjective or onto when every value in the output set is covered by at least one input. And finally, bijective functions are both injective and surjective, meaning every input is matched uniquely to every output. These types helps us understand whether a function can be reversed, fully cover its target, or avoid duplication, critical when working with encryption, database, or algorithms. Here so we see the examples to show how functions behave. This slide gives a general overview of how graphs help us understand functions visually. By looking at the shape of graph, we can quickly see which input are allowed, called the domain, and what kind of outputs the function produce, called the range. It makes it easier to understand the domain and the range of different types of functions. Here are some examples where sets and functions appear in real world tech. In databases, a join operations works like a set interactions. In search engines, combining the keywords filters result using union and intersections. In machine learning, models are functions that map input features to output labels, and in the cryptography, secure systems use bijective functions to encrypt and decrypt data. These concepts aren't just theory, they are used in tools we rely on every day. To wrap up here are some key points. Sets help us organize data, and functions let us transform and map that data logically. Understanding how they work gives you a strong foundation for topics like calculus, databases, machine learning, and cryptography. Thank you.